Hello everyone. So in this lecture series, I will talk about the facts and HVDC. So this is the lecture one, first lecture. So here I will explain that introduction to facts, opportunities to facts, then the basic types of facts controllers, basic description and the function of facts controllers. Okay, introduction to facts. So what is facts? So facts basically stands for flexible AC transmission system. So it refers to the collection of power electronics devices that enhance the power transmission, power controllability, power stability, then the capacity of alternating current transmission system. So what is the origin? So this concept of facts was introduced by Dr. N.G. Hingorani from Electric Power Research Institute. We will see what are the key objectives, core principle, and why facts is important. What are the main benefits of facts? What is the key objectives? So main objective is to improve the reliability and efficiency of the transmission network. Improve reliability and efficiency. So this is the objective. This is the one objective of these facts. Now what is the other objective? So other objective is provide dynamic control over power flow. Second objective is dynamic control. Dynamic control of over power flow, and other objectives are that integration of renewable energy sources, then maximum utilization of existing infrastructure. So these are the main objectives of facts. Now what are the core principle? So principle is that facts device use fast acting power electronics device like thyristors or IGBT. So use thyristors, IGBT to regulate the voltage magnitude. By using this, it can easily regulate the voltage magnitude, then the control phase angle and adjust line impedance. So why facts is important? The traditional mechanical based solution are very slow and less precise. The fax device provide real-time control. So fax device provide real-time control, control of transmission parameters, and support the evolution of smart grids and modern power systems. So that's why fax device are important. And then what are the main benefits? So main benefits, they increase the power transfer capability, then enhance the voltage and transient stability, enhance the voltage and transient stability, then reduce losses, reduce losses, improve power quality, So these are the main benefits of facts. Now we'll see the opportunities. So what are the opportunities of facts, that flexible AC transmission system? So fax device present numerous opportunities in modern power systems. Especially it's addressing the challenges related to the efficiency, then the system stability, then integration of renewable energy. So these are the some opportunities of facts. that this increased transmission capacity, enhance system stability, voltage regulation and reactive power support, power flow control. So we'll understand one by one. So what is how increase transmission capacity? Maximize the utilization of existing transmission infrastructure. Utilization. um, Transmission infrastructure. So by using this, it can increase the transmission capacity. So by controlling the power flow and reducing that congestion, they are referring, and it increase the utilization of existing transmission infrastructure. Then enhance the system stability. So effects improves both transient and dynamic stability. It can improve both transient and dynamic stability. Dynamic stability by providing fast acting voltage and then power flow control. By providing fast acting voltage and that power flow control. Then the voltage regulation and then reactive power support. By dynamically managing reactive power, it's by dynamically managing reactive power. Reactive power FACTS helps to maintain the voltage level. FACTS helps to maintain the voltage level. Then the power flow control. So FACTS are precise control of power flow on selected transmission paths. Then the improve power quality. They help in reducing voltage sag. It's reduce sag, reduce flicker, then reduce harmonics and resulting in cleaner and more reliable power supply. So this result in more reliable power supply, more reliable power. And then the renewable energy integration. So FACTS device use the stable and the efficient integration of variable renewable energy sources like solar and wind into a grid by supporting voltage and frequency control. So this is only possible by using that FACTS devices. Then reduce transmission losses. So by optimizing reactive power flow and maintaining voltage profile. By optimizing the reactive power flow and maintaining voltage profile. By doing this, it can reduce the transmission losses. Then support the smart grid and flexible operation. So its FACTS contribute to the development in the smart grids by enabling real-time monitoring. So by using that real-time monitoring, by doing this real-time monitoring, it can increase the grid stability, or it can develop the smart grids. Then the operational flexibility. So in FACTS provide operates with more control over grid condition, allowing better management of maintenance, scheduling and energy operations. Then the environmental benefits. So by improving transmission efficiency and by construction of new lines, FACTS indirectly reduce by reducing the construction of new lines, effects directly reducing the environmental impact and land use. So these are the different opportunities of facts. So move to the next slide. So here we'll see the basic types of the facts controllers. So there are different types of facts controllers are available. So these facts controllers are broadly categorized based on their connection, means how we are connecting these devices with the power systems and their functions. So these controllers use the power electronics devices to manage various electric parameters like voltage, impedance, phase angle. So basically there are four basic types of controllers are there. One is shunt controller, series controller, then series controller, then series shunt controller is there. So what is shunt controller? So basically what is the connection? So first we'll see the connection. So what is the connection of this shunt controller? So it's connected in parallel with the transmission line. Parallel with the transmission line. Then what is the function? What is the function of this shunt controller? So basically it's used for voltage control. And reactive power compensation. Reactive power compensation. So what is the examples? Example of this shunt controller is Hvdc, then STATCOM. So these are the example of shunt controller. As this static var compensator, this is static var compensator, and this is static synchronous compensator. STATCOM. Then the series controller. So what is the connection? So here we will see the connection. So in case of that series controller, it is always connected in series. And what is the function? What is the function of this? This mainly control the power flow by modifying the line impedance or phase angle. Control the power flow. Series controller main function is control the power flow. And the example. So what example is TCSC, thyristor control series capacitor. This TCC thyristor control series capacitor. Then SSC, the static synchronous series compensator. So these are the example of series controllers. Now we'll see that combined. We'll see that combined series controllers and combined series shunt controllers. So here also, what is the connection? So what is the connection of this series controller? Basically, these two or more series controller in different lines or same line. Means the two or more controllers are connected in series. Two or more controller in series. Two or more controller in series. This is the connection. And what is the function? So what is the function of this series controllers? So mainly coordinated control of power flow across multiple lines. Control of power flow. Multiple lines. So this is the function of this series controller. Now what is the example of this series controllers are IPFC, that is interline power flow controller. This is the example. Then combined series shunt controller. So this connection is one part is connected in series and another will be in shunt. Connection series and shunt. So this is the connection. Main function, it's offer comprehensive control over voltage, impedance and phase angle. Function, control voltage, the voltage, impedance, and phase angle. The example is UPFC. UPFC is the example, that is Unified Power Flow Controller. Is the example of series shunt controller. Then we'll see the basic description and function of controllers. So first we'll see the shunt connected FACS controller. That shunt connected FACS controller. Shunt connected FACS controllers are a device connected in parallel with the power system. Shunt means from this board we can say that this will always, this type of controller is always connected in parallel with the power systems, and their primary function is to inject or absorb reactive power to regulate the voltage magnitude, improve power factor, and enhance system stability. So now we'll see the little more what is the function of these controllers. So mainly it's maintain the voltage profile, maintain the voltage profile, maintain the voltage profile along transmission line, then provide dynamic reactive power compensation, dynamic reactive power compensation, then improve transient and dynamic voltage stability, transient and dynamic voltage stability. Then reduce transmission losses. So these are the different functions of shunt connected FACS controllers. So what are the main types of shunt controllers? Now we'll see the different types. What are the main types of shunt controllers? So that is SVC, that's static var compensator. So mainly in this, what technology use this static var compensator? Mainly thyristor control reactor and capacitor is using this SVC. Main operation is to adjust the reactive power by switching inductor and capacitor. Then use where we can use this for the voltage control in high voltage AC networks. And advantage of this type of controllers is very simple, robust, and it's a proven technology. And then other types of shunt controller is STATCOM, that's static synchronous compensator. So this main technology is that voltage source converter. It is that voltage source converter, and it acts as a controller reactive power source or sync by generating a voltage with variable magnitude and phase angle, and mainly it's used for fast and effective voltage regulation, particularly under varying load conditions. And advantages is superior dynamic response and performance compared to that SVC. So these are the main two types of shunt controllers. Now if we see the comparison of this SVC and STATCOM, so in case of the technology, it is thyristor based and this is converter based. Then response time is slower, this is slower, and this is very fast. Size is larger. This SVC is very large in size, and it is more compact in size. And low voltage performance degrades. Its performance degrades at low voltage, and its performance is very good in case of that low voltages. So these are the comparison of SVC and STATCOM. The shunt connected controllers are, so this is very important point, that shunt connected controllers are essential for maintaining voltage stability in long transmission line, especially where load fluctuation or renewable integration is significant. So this is the some functions and different examples of shunt controllers. Now we'll see the series controllers, series connected FACS controllers. So this series connected FACS controllers also they are from the name we can say this type of controller will be always connected in series with the transmission line, and that primary role of this their primary role to control the line impedance, thus directly influence the power flow, increase the power flow through the line and improving the stability, voltage profile and load sharing. So what are now we'll see that function of these series controllers. So mainly it's control the reactive power flow, it control active power flow, control active power flow by adjusting line reactance, then the improve system stability, improve, then reduce losses reduce, then so these are the functions of that series compensators, series connected controllers. Now that what are the main types? So main types of that is these series controllers are series controller TCSC, that thyristor control series capacitor. So mainly what they're using that thyristor, to have vary the impedance and the capacitor reactor in the capacitor reactor network. Then the operation and they control the effective reactance by switching in and out portion of the capacitor to reactor. Then so what is the benefits? The rapid power flow control and oscillation damping. And the other type is TSSC, that is thyristor switch series capacitor. So these also use the thyristor to switch capacitor banks on or off. This operation provides discrete step of compensation. The benefit is simple control and less complex than TCSC, that thyristor control series capacitor. This triple SC, that static synchronous series compensator, this is a voltage source converter. This use that voltage source converter technology in operation. It injects a controllable AC voltage in series with the line, and the benefits is dynamic and the independent control of both real and reactive power. So this is the advantage of this triple SC. And then if we see the comparison of these three controllers, so that control types, so it's continuous thyristor phase control, then this is a discrete on off switching, this is continuous converter based, then voltage source converter based. So response is fast, this is medium, this is very fast. Reactive power control is possible by using this, and this is very limited, this is also possible, this is also okay. Then the real power control, this is indirect, this is not possible, and this is okay. Now we need to know one important thing of this series controllers. Series controllers are especially useful for long distance transmission and loop network and areas with charging powered demand patterns. So this is all about that series controllers. I will see the combination of series and series FACTS controllers. That this combined series FACTS controllers involve that two or more series connected controllers to operate that in coordination across the different transmission lines within the same corridor. And so what is the main function? We'll see the main function of this type of controller. So main function is balance the real power flow between multiple lines, balance the real power flow in multiple lines. Then the improve transmission efficiency, then the enhance voltage stability, then control interline power transfer, control interline power transfer. So these are the some functions of series FACTS controller. So the main type of series FACTS controller is IPFC, that is interline power flow controller. that interline power flow controller. This is use a set of static synchronous series compensator, one for each line connected by a common DC link. So main operation is each SSS injects controllable voltage in the respective line. Suppose there is a two line, so in each line one this SSC is connected. So each SSC injects controllable voltage in the respective line, and the DC link allow real power exchange between lines. And its capability is independent and coordinated control of active and reactive power. And then the what is the functions? So what is the benefits? If we see the benefits of benefits of that IPSC, it's enable real-time balancing. Real-time balancing. Real-time balancing, then renewable energy integration. Renewable energy integration. Renewable energy integration, then power quality, it improve the power quality, then multi-line UPFC. So these are the benefits of this IPFC. Application in parallel transmission line corridor where the load sharing is uneven, there we can use this series controller, and to enhance the transfer capability of connection capability, we can use this series controller in smart grids for intelligent and flexible control of power routing. We can use this series controller. Combined series controller like IPFC are powerful tool in modern mesh transmission network with high variability and distributed generation sources. Now we'll see that combined series shunt FEX controllers. So this combined series shunt FEX controllers integrate both series and shunt compensation in a single coordinated system. This device provides simultaneous control of voltage and power, making them most powerful and the flexible types of FEX controller. So this is this series shunt combination making the most powerful and the flexible type FEX controller. So main key function is the voltage magnitude and the line impedance control. It's control voltage magnitude line impedance, alternate line impedance and phase angle, delta. Then the independent control of real and reactive power, independent control of real and reactive power. Then the system stability, So these are the some key function of the series shunt controllers. So main types of the series shunt controller is UPFC. So this is the main types of that controller is UPFC. The technology is combines a STATCOM, means shunt converter, then SSC series converter. So this is the combination of series shunt converter. Shunt converter injects the absorbed reactive power to the control bias voltage and supply DC link. Then the series converter injects controllable voltage in series with the transmission line to control the power flow. Capability is real-time control over voltage, then the real power and the reactive power. Seamless power flow, routing and the load relief in congested networks. And there is another type is there. So there is the advanced variant of this UPFC, that is GUPFC. So that is generalized unified power flow control. So this is generalized unified power flow control. Generalized unified power flow control. The application, we say there is the voltage regulation, then the congestion management in the high stressed power corridor, enhance stability in long distance, and then the integration with renewable energy sources for better grid adaptability. So these are the applications of series shunt controllers, and these are the advantage. This full power flow control, adjust real and reactive power independently, then improve voltage profile, dynamic shunt compensation, then enhance steady state stability, adapt to the rapid grid changes. So these are the advantages of this series shunt controller. This combined series shunt controller like UPFC represents the most versatile and the complete solution. It's provide most versatile and the improved solution, versatile and a complete solution of facts family, enabling high performance grid operation under diverse conditions. So these are the different types of that facts controllers and their functions. So in the upcoming lectures, so we'll talk about that elaborately, these series controllers, shunt controller, and that's combined controllers, combined series controller and combined series shunt controllers. Thank you, Brian.